Awesome. Thanks a lot, Stavro. Thanks a lot, everyone, for being here. I'm Antonis, as you briefly heard. And today we're going to talk about Docker and containers. So we're going to briefly see the technology, how it works, and some pros and cons when using it. And at the same time, we're going to see how we're going to use this technology in order to be able to run local developer environments. So a few quick words about me. I'm a software engineer at a company called Platform Estates, where we provide hosting on the cloud, really easy and nice. Feel free to check it out. It's really easy to use. I'm part of a program called Docker Captains. So Docker Captains is a program that allows us to do presentations like this one, and at the same time get more information, more deep dives on the technology. So I really love the technology, and this allows me to learn a lot of things. And if you happen to speak Greek, we have a nice podcast called Mikri Kouveda. You can check it out. We have 2 episodes in English, so sorry if you're not Greek or do not speak Greek. I generally write a lot of Python, so this is my language of choice, and Go, plus Node.js, PHP, or whatever comes in my hands, but these are the 2 languages that I mostly enjoy. I love Docker and containers in general. This is one of the technologies that really changed my life, and I hope that it will do the same for you. Some people tell me that whatever comes in my hands becomes a container. So I really like this, and you'll see this theme throughout the presentation. So what are my goals and hopefully your goals for today? We'll start by talking about Docker and containers. So we'll see what is that technology and what it allows us to do and to not do. And then we're going to see how we're going to use this technology to create local development environments that are really easy to use, reusable, and generally make our life easier. I prepared 2 demos, but my local computer is not operating in perfect sense, but I'm hoping that the build that's running on the background is going to work until the demo time happens, but we'll see how it works. By the end, we're going to have a quick quiz, so feel free to stay, and whoever stays and takes the quiz will win a few stickers and some chocolates. So the first one on the quiz will have the chocolates. The rest of you can have socks or stickers. So I'll be happy to share this with you. So enough about all the introduction and all the initial things we're going to talk about. So let me quickly set my timer here to make sure that I don't miss the time. So the first question that comes into someone's mind is, why should I care about containers? I've heard about containers, maybe another team in the company is using them to deploy our applications in the cloud, or I've seen some presentations. But why should I care as a developer for containers, and how could containers improve my day-to-day life and my way of creating applications? So before answering that question, I'm going to share a story, because with a story, it's easier to understand the problems that we face every day, and many times we miss to acknowledge them and try to solve them. So let's say that Alice comes into a new company. So you have a new hire, you're really excited, she's excited, so she's going to be able to code and create value for the company. And a first small feature is assigned to her so that she can start developing and onboarding in the code base. So Alice downloads the code base from your favorite Git hosting system, let's say GitHub, has the code locally, but once it tries to run the application crashes immediately. So she says, okay, maybe I didn't read the documentation, so she goes back to the README and sees a huge list of different instructions on how to set up her local environment. So she starts following all of those instructions, and after a few hours, because the instructions were really good, she's at the point where she thinks that everything is ready, so she goes back and runs the correct command to bootstrap the environment. The environment, though, does not start again, because the last developer that was in the company forgot to update a Linux package to the latest version, and this latest version was really needed for the application to run. So Alice is a bit disappointed because she failed and she had to ask around, but still she has a developer who's kind enough to share their knowledge with her so she can start developing the application. So after pair programming for a few more hours, then the next day she's ready to start developing the application. So as it goes, it boots the computer, the virtual machine on her local computer to be able to develop the application, and she starts developing things. So she's really happy, and when she pushes the code to the CI system crashes. And she understands that a feature that she was using locally is not available in the CI system. And when she asks around, she finally understands that, another package was installed locally, but not on the CI system. So the CI system is not up to date to the local environment, and that is also different from the production environment. So you start seeing a pattern here where you have very different environments in your local computer, on the CI/CD system, on the production environment. And all those environments are very different and really hard to keep in sync and know what happens and what is installed where. So this is a very common story, and it's not about Alice, it's not about your company or another company, it's a very common thing. And what we are going to see today is to see how we can describe all those services, describe our application, and make it packaged so that we can easily develop locally, run our tests and everything on the CI, and also deploy to production without having any communication issues between all those systems. Because at the end of the day, it's not a technical problem, it's a communication problem. It's a communication problem between the developer that has bootstrapped the local environment, the team that has prepared the CI/CD environment, and the team responsible for production. So with containers, we probably use them in our staging and our production environments. So we have many different environments that are running that soon. So maybe you have some staging environment that you plan to move to containers in production soon, or maybe you already are there. But in all those cases, it's really important to know that containers will be there at some point. Most CI systems are using Docker and containers to run your jobs. So whether you use GitLab CI, GitHub Actions, or whatever CI/CD system you use in your day-to-day life, this system most probably runs a container somewhere in the cloud, and this container is the one that is running all your tests and everything and makes sure that your application is running. So whether you like it or not, containers are going to be there most of the times when you deploy and you develop your applications. So why not also run your local environments inside containers and make sure that the same environment that runs on your CI in production runs on your local environment? Of course, we need tools like Docker Compose, and we need to do some bootstrapping. It's not that everything comes for free. And as I like to tell in all of those presentations, when you introduce a new technology, you also introduce new problems. So you need to make sure that you introduce the technology for the right reasons, and the problems that you solve are more than the problems that you introduce. Because if you introduce more problems, maybe you're a pain in the ass and not an actual problem solver here. So before going to see how we're going to use containers in our day-to-day life, I think it's really important to understand what is a container. Because containers are oftentimes used interchangeably with VMs or with other processes, and we need to understand the differences. So what are the pros of using containers and what are the cons of using them? So the most common question is virtual machines versus containers. Why can't I use a local virtual machine to host my local environment or use virtual machines in my production or CI systems? So first and foremost, it's not like you are either a container fan person or a VM fan person. These two technologies can coexist. And most of the times when you run containers inside VMs in a cloud. So when you have your AWS or Azure or whatever infrastructure in the cloud, then you use VMs there, and then on those VMs you deploy containers. So it's not like choose one or the other. You need to understand both and use both. So containers, or maybe say virtual machines, are more like what I would call your vacation house. In your vacation house, you are more isolated, you have everything done your way, but at the same time, you have more cost. So in your vacation house, you need to make sure that you pay for electricity to come to your house, because this does not pre-exist. You have to do your own plumbing. You have to do everything by yourself, and you have to do it your own way. So for certain circumstances, a vacation house is a very nice thing, because you want to go there and you want everything isolated in your own way. While containers are more like flat apartments. In a flat apartment, you don't have as many costs, because you have shared plumbing, shared electricity, you have the same garage with other people in the same building, so everything is shared. You might have one neighbor that always complains, or you might have all those situations, but still the cost is a lot less. So containers are the same thing. If you have applications that behave well with each other and can be deployed one to the side of the other, then this is a very good use case for containers. So you can really nicely package your applications and deploy them in containers, while on the other hand, if you have very specialized applications that need custom kernels or things that cannot be installed inside containers, then for those applications, you can still use your virtual machines. The one very interesting benefit, let's say, of using containers is that containers are very lightweight and fast. So containers are not actual machines. So in a virtual machine, you need to virtualize everything. You need to make a virtual CPU, a virtual RAM, virtual disks. Everything needs to be, everything that you have as hardware on your local computer needs to be virtualized and at some point be some kind of software running for your virtual machine to be running. With containers, since we have all this shared plumbing, shared everything, all these things are pre-initialized, and the container just needs a very thin layer to be initialized before it can run. So this makes containers very lightweight and very fast, but at the same time, not as customizable as VMs, as we said. So what are those things called containers? If we go, I think this is from Wikipedia. This is copied from there. So if you go to Wikipedia and we ask what is a container, containers are a set of tools and features that we can find in the Linux kernel. So it's not something that we say containers start in the Linux kernel, but we use a combination of different tools and features in order to be able to jail and limit a process. So first, we create a virtual world for this process. So this process is exactly the same as the one sitting next to it, but we put a wrap around it. And these things are usually called namespaces, if you heard about them. And then we use things like CPU groups and memory groups in order to limit the resources that each container can utilize. For example, if you have a shared pool, everyone is allowed to bring a certain number of people in the pool. You're not allowed to have a big party unless you have the acceptance of the rest of the residents. In the same way, when we run multiple containers, we don't want single container to take all the CPU or all the RAM inside the virtual machine, because at the end of the day, this has no point. We have a flat building, but this one bad neighbor is occupying the whole building. We don't want that. We want everything to be in their own apartment. So two are the most important things. We use things called namespaces in order to create a virtual world for this process. So this process thinks that it's alone, although it isn't. And the second thing is that we use C groups or memory groups and other tools to limit the resources that are available to our process. So, okay, this is all about containers, but Docker is very specific, so it's a different technology on top of those things. So what was the secret sauce? What was the magical thing that Docker actually brought into the play that made this technology stand out? Because you might have heard that already, but containers were not introduced into the computer science world the last 8 years, or how many years Docker exists. Google has been using containers for a long time. Things like Heroku or Platform S8, we used containers before Docker existed. So you see many different companies have used containers, but Docker was the first one that introduced containers to the masses, to the normal, as I like to say, people. Because all of us were not, deep dive Linux system administrators to be able to run all those tools by ourselves. And Docker created a nice wrapper with nice developer experience on top of those tools. So we can do things like Docker run, and then spin up a new container from a certain image and run it on our local machine. So the things that personally I prefer the most when we talk about Docker and containers is the image format. It might be really easy to do Docker run Ubuntu or Docker run Alpine and run a Linux distribution locally. We think that that's a simple command, but behind it, it's the packaging format that makes all those layers that you see downloaded and other nice things that Docker introduced and make all this experience a lot nicer. Also simplicity, because as we said, a single command does everything. And it also introduced things like pluggable networking and volume storage. So containers can now have different kinds of networking depending on your needs. You can also create your own drivers. So you have all these interfaces so that you can develop on top of it. So now that we have a small introduction of containers in general, now I would like to go more deeply and see local first development. So this is actually a friend of mine, Yorgos, told me that term recently on LinkedIn. So thanks, Yorgos, if you're here or if you're not. So local first development means that we can have the same stack locally, and we can run all the tests that we run on our CI, and we can deploy the application in the same way locally that we do on our CI or production environment. So you see many times that it's easy to create a small feature locally, but if you have a complex system with different microservices, different versions of databases, and all that kind of stuff, this is not easy at all to run locally. So by optimizing and making sure our environment runs locally using tools like Docker Compose, we can easily create local first development environments. What does that mean? This means that we can use tools like Docker Desktop and Docker Compose. So Docker Desktop is the application that you can locally install on your computer and run a Docker-ready virtual machine on your computer. You see, again, we still need to run a virtual machine, and inside this virtual machine, we need to run containers, because my Mac computer or your Windows computer might not run Docker natively. So that's one thing. And then we have a tool called Docker Compose, which helps us describe the whole stack of the application and be able to run it all with a single command. The other thing is that by doing that, we can also introduce things like optimizations. Many times we don't want to run the whole stack all at once, or we want to be able to run this with debug mode on or debug mode off, or different settings so that we can easily customize and make sure that our local environment is the same with the production environment, because you have other things like multiple different deployments. Let's say that we have different brands all running the same code base, and you need some kind of customization so that you can bootstrap this environment locally with different commands. So by specifying all these options in this Docker Compose file, we can easily do simple changes locally, and a different stack gets bootstrapped with a different theme or different settings or different features enabled or disabled. So it's really easy to handle, and making sure that all this is documented, because we all know it. If we don't document something in code, we are not going to document it at all. So this allows us and gives us a place to put all this information and all those things on our environments. The second thing is that by creating everything inside a local Docker container or multiple Docker containers locally, is that we can easily have reusable environments. Because as we said in the initial example, Alice could not easily replicate the environment of her colleague. And this is a very common use case, because oftentimes developer environments locally tend to have a drift and change from the one that we initially all created. So Antonis' environment might be different from another colleague working next to him. So it's really important to have all those things documented. So each time we need to do a change, we change something in code, and then the new code gets deployed when the other developer pulls. So this makes sure that those environments keep to be up to date and up to sync. So we still use the same thing. We have the Docker Compose file, the Docker Desktop for running those containers and everything, and we have everything stored in Git. So if you have Git, you have the history, when environment changed, why it changed, and how you are going to use it again. So whenever I update, for example, the database version on my local environment, I do not do it only locally, and I need to notify all my colleagues. But the moment they pull the new code from the Git repository I'm having, then they're going to have the same code running on their machine. And this is really important. It seems trivial, but you don't want to know how hard it is to have to lose like half a day or maybe a full day trying to debug a bug, which was only introduced because you do not use the latest Python version or the latest database version that all your other colleagues are using on their own local environments or on your production system or your CI system. So let's speak a bit more about Docker Desktop, what it provides us as a tool, and how we can leverage it to make sure that we have nice developer environments locally. So first of all, Docker Desktop is running a Linux virtual machine. So this is a thin layer. So it's a very specialized virtual machine that's only used in order to run containers. It's very safe and very targeted to that use. And this means that we can have the same experience. Either we have a Linux computer, a Mac computer, or a Windows computer. So we have our cell tools, so our user tools running on our local platform in its case. But our actual application runs in the same environment inside this Linux virtual machine, which is the same for everyone. So this is a very nice standardization that allows us to make sure that environments run in the same way everywhere. Also, Docker Desktop is also available for Linux. So this is an even better optimization, even for colleagues that run Linux on their local machine. Excuse me. So the other good thing about running Docker Desktop is that it installs all the other satellite tools that we need in order to run those containers locally, like Docker Compose, the Docker CLI locally on our own computer, and everything else like BuildKit or the other nice goodies. So all those things are really important, really easy to install with Docker Desktop, and it allows us to mount local directories. So I can have a directory in my home folder, let's say, and then mount this inside the container to be able to develop applications. So we have the whole package. Of course, one really important thing when it comes to developing applications locally is how do you build those containers. And by building those containers, by building those containers with BuildKit, which is the new tool for building images, we can have things like better cache optimization and other nice goodies that we're going to see in the examples later on that help us make this faster and also share more things so that our day-to-day life is not waiting for the compile to finish. You've seen all these comics, after all, but actually doing work, which is what we do. We create value by writing code. We don't create value by waiting for a build to finish. So this lets us optimize all this process. And of course, if you're a Windows user, I would highly recommend to use WSL2, which is the Windows subsystem for Linux. It was maybe the only reason I switched briefly to Windows a few months ago to test it out, and it's really nice and helps you have a very optimized VM in terms of memory and CPU running on a local machine without needing to know how it works. So let's see a few tips and tricks that you can use when you have your Docker Desktop installed locally. First of all, you can easily reference the host machine. So this is really important if you have other services running locally and you want to connect to them through your container. Since your container runs inside this network inside Docker Desktop, you need some kind of way to link away to your local machine. So if you want to do that, you can use host.docker.internal, which is a very specialized domain that links back to your machine. And this is very helpful if you have other services that are not containerized running on your local machine, or even other Docker stacks running on your local machine that you want to connect to them. Also, with a simple checkbox, you can use Docker Compose version 2, which has very nice features and goodies. I think there is also an environment flag that you can use, but the setting in Docker Desktop is even easier than that. And with Docker Desktop version 2, it's really easy to make sure that your application can use and leverage all those new features because the legacy Docker Compose is no longer being used. And if you're on Mac, I would like to recommend to use VirtueFS. VirtueFS is the new file system, which is even faster. So a very common complaint for people using Docker Desktop for local development before was that the file system was very slow. If you enable VirtueFS, you might lose some of those features. So some very specialized things like mounting the Docker socket might not work. But apart from that, it's really easy and handy to work. Then we have Docker Compose, which is, of all times, my favorite tool. So Docker Compose is a tool that allows us to describe our whole stack, database, caches, web servers, builders, whatever you need, in a single file. And this file is version controlled and very pluggable and configurable. So this allows us easily to be able to share the same stack everywhere. I think this is like a magic file, in my opinion. And also, there are many systems that can use Docker Compose to even deploy your application, although this might not be the case for everyone here. Also, you have a file called dockercompose.override.yml, which allows you to override some settings. So if you have some specialized local settings that you want to to run and extend this Docker Compose that was provided in the repository, you can easily use this file and override those settings and have, let's say, a custom flavor of the application, because you might need some specific instructions or specific configuration running, as we told. And also Docker Compose reads the .env file, so a file stored locally, which is usually Docker ignored, that you can use to override specific settings. So let's say that I have a setting called enable debugging. This might be false by default, but with a simple change in the .env file, I can easily update the setting, and the next time I run the stack will have debugging enabled right there. So the cheat sheet is that you can use some kind of local development optimizations to be able to run your services in a better way, like installing node modules. You might have heard of them. They're very big, and many of them in your application, and you can install node modules in a separate volume. This means that they're going to have a native mounting from Docker machine to Docker desktop, to your container, and this will be faster. And at the same time, usually if you're on a Mac, you might have some specific node modules that are only runnable on Mac or on Linux. So this creates some conflicts between your local environment and the container environment. So by using a volume, you can override that. You're going to use compose docker CLI build equals 1. This makes Docker Compose use the local Docker CLI to build your images, and this immediately enables all these nice features in BuildKit that you can have better caching, you can mount the local SSH socket to the container, so if you need to do some pooling of submodules that are private, you can do that easily with BuildKit and build your image, which was not a nice thing to do previously. And you can also, as we said, install dependencies both locally and in Docker Compose. So locally, you have your local code editor having the dependencies so that you can do things like autocomplete or navigation between your code base with your local editor. But at the same time, you can install them inside the container so that your application runs. So this seems like a duplication, but it's a nice solution until we go to the containers that run also your developer environment, which will be the last thing we'll see today. So now I'm going to go back to my editor and see if the build started. So I think I'm happy. I have commented out some things that were very slow to download because I needed to rebuild everything from scratch, but the idea is there. So let me make this a bit bigger. So when you are creating Docker files, as you said, Docker files are the recipe that outputs the actual image. So it's really important to make sure that all those Docker files are, first of all, configurable. So if I need to update the Python version, I can do it once, or the Node version, or whatever I need. As you see, I have a very small cheat here so that this demo actually works. I can have Python. So all these things are different layers. So container images are organized within layers, and each layer represents a different hash. So if the layer does not change, then I can have caching. And it's really important to organize our Docker file so that things that change slowly go up in the Docker file so that they are more cached, and things that change more often go to the bottom of the Docker file. So right here, as you see, first I install dependencies. We use Poetry in this example. And then I use a special feature called mount. So I have a global cache for Poetry installations in my machine. And every time I install a package, it's being downloaded once and not once for each project. This is a very nice goodie used with BuildKit. And then I have things like my code and everything. So you see that each layer represents a different thing. So here again, I have the node thing that was breaking. So what happens here is that I just downloaded this repository from the internet. I don't have any access to it. Or not any access, but I don't have an environment running. What I need to do is do Docker Compose up. So with a simple command, this is going to read both this Docker file that I was showing before, plus this Docker Compose file, which defines things like the web service and the ports that it listens. So I know that if I go to port 8000, I'm going to see an application running. I have all my specific configuration here. And as you can see here, in some configuration like skipdbjx, I have a default value, which is 0. So by default, I don't want to skip them. But if I want, for some strange reason, to override this, I can go to the .env file And let's hope that I don't have any secrets in here. Okay, I won't open it because I think I have some secrets in there, and I don't want to have this on video. But the idea is that if I go to the .env file and I update the skip db checks setting, I can easily override this and make sure it works as I want. I have dependencies like depend on my database, and then I have my database defined here, so I'm using Postgres. So everything is being run with a single file. And as you see here, my application is running, and hopefully it's going to be here. So if I go here, I can see my application running. So with a very easy command that needs to use, I have a full thing that's running on my local machine. It has its own database, its own cache, its own everything. Everything is separate between projects, so it's a Docker Compose app. It's creating a new stack named after the directory I'm in. So if I have two projects with different directories, then this will be two different stacks being deployed there. So it's really easy to organize in one file. Too many things here. Let's go back here. So before we end, I want to show you some, what I say, bleeding edge stuff. So we see things like Docker containers running, the IDE and VS Code being part of this. So you can find more things in here. But if you search for Docker developer environments or VS Code remote containers, you are going to see this. And this is really nice because you can have your actual VS Code server running inside the container, which allows you to do things like autocomplete, code navigation, and everything running inside the container. So this is a really optimized setup. Although this is not ideal, to be honest. Right now, it has some bits and pieces that are not perfect, but we're getting there, and we're going to go there. So the idea is that we have the production container, and then we install things like developer tools, then we have the VS Code server, and then we have our code. So we have all this stack inside the container, running locally, and we can easily develop applications. So I'm going to skip the dev container example since it's not working perfectly, and I have just a few minutes left. So as we have questions, and you are thinking about them, I would like everyone who wants to go to kahoot.it or scan the QR code, which is going to be shown here. And we're going to play a game, and the winner is going to get this chocolate. So if you were very cautious in the presentation, you are going to see that. If you go to kahoot.it and then input this pin or just scan the QR code, then your phone will become a remote control. So I'll give you like 1 or 2 minutes to get in here. And if you have any questions in the meantime, no questions?
Questions, anyone?
Questions as, okay, I have one in the back. Hi.
Hello, I see you mentioned Postgres. I've been into this community for over 20 years. Mm-hmm. And the consensus on Docker is not in favor of Docker. I mean, inside this community, I still don't know how to judge myself, although I haven't found yet a very good reason, to Dockerify, let's say, anything. And if we take into account that a serious upgrade from 11 to 14 maybe is work over 6 months, mm-hmm. right? How would you persuade such a person that it's harmless, or I mean, what's the current state of affairs regarding
Okay,
this?
I'll answer it as should I run a stateful service inside the container? So because I mean it's not only for Postgres, it's for every database and every stateful service out there. It's not.
It's specific for Postgres because I've worked with MySQL as well, and there's no MySQL is
more compatible.
Tolerates a lot of things that Postgres does not.
So I've been running Postgres both within containers and outside the containers. I couldn't say it's not harmless because you need to know Postgres in order to run inside the container the same way that you need to know Postgres in order to run in a VM. So I think that Postgres has a very nice upgrade path. I would use it personally, but only if I knew how to run Postgres. All the other times I would go to a managed service, to be honest. So this will be better handled by them. I don't think I can easily answer this in a simple sentence, but the idea is that if you know how to run Postgres and if you know how containers work, then you can make this work. But if you don't know one of them, then better try an alternative solution. It's not my best recommendation.
Any other questions?
Okay, let's start the game and maybe we can do questions because I think I have maybe a couple of minutes. Okay, so there's a start button here. So the idea is that you see a question and then you answer on your local device, and then we have the leaderboard. So get ready and start the quiz. So what file do you use to change compose setup locally? Is it Docker compose override, update, local, or YOLO? Oh, too many answers. Nice. So it's Docker compose override. The two that said YOLO, you'll have an extra sticker. Thanks for that. That was a tricky question that you have extra points. So Sarah, this is the first one. Let's see how it goes. Also, speed matters. Containers are a special feature of the Linux kernel, yes or no? So this is one of the questions that we do at the final exams in school, where you don't really know what is the answer. So I needed to put some entropy in the results. That's why it's here. So false, correct. It's not a special feature. We use multiple features, and we cannot find. Saradis is continuing to have the lead here. Oh, so how can I easily run a language server when developing locally? So that was briefly mentioned at the end of the presentation. To give a hint here. Okay, we had two correct answers here, so most of you were the correct ones. And let's go to the final one. We have some changes in the leaderboard. Oh, we have some movement here. So final question, should I run my developer environments in containers? True or false? And now maybe we have time for another question, or we're out of time? Kind of. Do we have any other questions before we see the final leaderboard?
I think we've got no more questions, Antoni.
Awesome. So let's see the leaderboard. The third one is Go Ioannis. Second one is Tol HC. First one is, do we know the winner? Sarat. Oh, he kept the first position in every time. So congrats. I have extra stickers, so feel free to reach out, and I'll be happy to give any more. So the first three come to get your socks and chocolate. I hope you enjoyed it, and have a nice day and continue the conference.
Antonis Kalipetis, thank you.